As we get ready to look at the examples for logarithms and graphing logarithms, it's important for us to take a moment to understand that the basic procedures for graphing logarithms is identical to the kinds of things we were doing when graphing exponentials. We want to identify the transformations beforehand if possible. We want to think about our base graph. We want to potentially graph the base graph first as a dashed curve so that we can show the progress and get partial credit if something goes wrong. We want to work to identify the asymptote equation. However, with logarithms, as we found out, with the initial preparation, the asymptote equation is going to be different. So here the asymptote equation is always going to be a vertical line. And it's going to start off with an x equals 0. Now I put 0 in quotes because it's not always at 0 if there's a horizontal shift. And identify the domain and range. And again, for a logarithm graph, the one thing we want to remember is that our range will always be from negative infinity to infinity. Our domain, on the other hand, is going to initially be 0 to infinity, but that will change just like, so I'll use quotes, that's relative to the problem. So these values of 0 and 0 to infinity will be impacted by the transformations. Alright, so let's get started on our first example. I see f of x equals log base 4 of x plus 1. So I really want to focus in on the base 4. So I can come over here and I can either write my base function as y equals log base 4 of x, or I can rewrite it in its exponential version, where you start with the base 4, raise it to the y power equals x. Now this is unusual for us to be raising something to the y power, but what we notice is that's why the values negative 1, 0, and 1 are in our y column, because it makes it easier for substitution. So 4 to the 0, I like to start in the middle, is 1. 4 to the first, I like to do positive numbers first, so 4 to the first is 4. And lastly, 4 to the negative 1, just like we saw earlier, is going to be 1 over 4 to the first, which is basically 1/4. Obviously, these values are still going to be reciprocal. So I'm going to go ahead and put those points on my graph and count them out. 4, 1, 1, 0, and then whenever it's a fraction, I just want to be relative. Now it's said up here in the instructions that I should do it as a dashed curve, so I'm going to come back and make sure that that's dashed. And I might even label it number 1 because it's my first graph. Now I'm ready to kind of look and see what kinds of transformations I expect to be happening. Let me pause for a second. Seems to be a little out of focus. Alright, that appears to be better. So we'll pick back up with the reflection and horizontal pieces. So when I look at my graph, now I'm ready to, at the equation, I'm looking to see if there are any negatives in front of the function, which I don't see any. So there's no reflection over the x. I'm looking to see if there are any negatives inside on the x, and I would argue again that there is no reflection. What I do notice is a horizontal shift, because there's a number inside, and numbers inside still affect the x. So that means that we're going to move left 1. And I don't see any numbers outside the function being added or subtracted, so I'm going to say that there's no vertical shift. So initially in our graph, we have x equals 0. So what I want you to do is kind of picture that line. I'll put a pen in its location. And if this whole graph moves left 1, then so does the pen. So it just moves from x equals 0 to x equals negative 1. And so when we go to write our asymptote equation, that's where it's coming from. It's coming from this shift left 1. And the reason the horizontal shift affects the asymptote is because it's a vertical asymptote. This is different than what you saw the other day with exponential graphing. Now we mentioned already that our range for all logarithmic curves will be from negative infinity to infinity, so we can do that. And personally, I like to look at the graph for the domain. So if I actually were to take all of these points and move them left one, so this guy comes to 0, he was at 4, he's now at 3. This guy was a little bit to the left of 0, so he's a little bit to the left of -1. If I graph those, so I'm going to just turn my paper to make the graph. This time I'm going to make it solid so that I know it's the final graph. And I'm going to actually put my asymptote in there. Now I want to make sure the asymptote's easy to see. Obviously I'm using a pen, so it makes it a little bit easier. But I also want to make sure that my branch of my logarithmic function is not crossing that asymptote. Sometimes I'll even make sure that I put the asymptote just a bit outside the graph so that it's easy to see. And then I notice that those points don't touch -1, and they appear to be to the right. And that's where I'm getting the -1 and bigger. So things to the right of -1 is what I'm seeing in the graph, and that matches my domain. And that's example 1.